To explain serverless computing and in turn AWS Lambda functions, let's picture a genie. And this genie will become important as we go through this analogy. So let's start by defining serverless computing, which at its core provides a service known as Function as a Service, or FaaS, F-A-A-S. And to fully understand Function as a Service, we need to go back and understand traditional computing hosting. That is, server computing before serverless became a thing. You see, back in the day of traditional hosting infrastructure, you would need to deploy apps and services onto physical servers, e.g. that included the provisioning, scaling, and all the relative costs that came with this physical server administration. And yes, that included all those physical trips you had to take in your van to the data center to maintain the server which was hosted in one of the data center racks. And this is where cloud service providers, CSPs, such as AWS, changed the hosting game forever. This was through the shared responsibility model, where generally the customer is responsible for cloud security in the cloud, whereas the provider is responsible for security off the cloud, e.g. the physical infrastructure, which can be managed virtually by the customer. And this new revolutionary approach to cloud server hosting and serverless computing essentially got rid of a lot of the red tape around traditional physical hosting infrastructure. Now, one of the key features of serverless computing is the AWS Lambda function, which basically triggers some developer's code in terms of what the app or service should be doing, and in turn this will then spin up the relevant servers that will be needed to run that code. Essentially, the developer doesn't need to understand or worry about any of the infrastructure, they just focus on their code which does what it needs to do. E.g. function as a service, because the function of the code will run and it will do all the functions needed without needing to worry about the infrastructure. Now you may be wondering technically how this actually happens, and this is where the genie from the start of the video becomes important. Because imagine that this genie only wakes up when it's triggered through a Lambda function. And this magic genie upon waking then creates all the relative servers that are needed, or servers if there's more than one, in order to run this Lambda function code. So all you need to do as a developer is focus on the Lambda function code and the triggers that will trigger this genie to wake up and do its thing, which means you don't need to worry about that traditional hosting infrastructure process. Now let's deep dive into the actual Lambda function code. So firstly, as a developer, you create your code which you upload to Lambda, which then becomes the Lambda function code. The next step would be to trigger the Lambda function code by using an event source, such as an AWS service or even a HTTP request, such as a website submitting a form, and when it does, this would trigger that event source. These triggers are important because your code will only run upon a trigger event. And it's worth noting that Lambda automatically handles all the server-related management that's needed to run that Lambda function for you. And this is the huge benefit of serverless computing and Lambda functions, because you only pay for the compute time used by your function. In fact, this compute time is charged by the millisecond. And of course, just like the electric meter in your house, the more compute or memory you use to run your function, the more it will cost you, but the less you use, the less it will cost you, etc, etc. So simply put, use Lambda to run code without thinking about servers. Although a technical caveat to note is that the maximum duration of a Lambda function is 15 minutes at the time of making this video, so do be aware of how long your Lambda function needs to run. Now, I just want to recap on another important concept which we touched upon earlier in the video, which is known as Lambda runtime environments, which you can think of a container-like environment wrapped around your code, which allows for different programming languages to interact with the AWS Lambda function through what is known as a Lambda runtime API. And the reason I wanted to recap that was because a common AWS exam question would ask you what the key components of AWS Lambda are, and these are functions, triggers, and runtimes. And finally, you may be wondering, well, how do you monitor all this Lambda function and whether it's successfully run or not? Well, you can use AWS CloudWatch logs, for example, as one of the AWS services to monitor this entire process. I hope you found this video informative. If so, please be sure to like and subscribe to help support this channel's growth. As I work a full-time cybersecurity job, and the time and effort and research needed to make these videos means I do not have time to actively promote these videos across YouTube. And so all your likes, subscribes and comments help push this video further and further up the YouTube algorithm. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.